Alright, welcome to 7.3 solving exponential equations. I'm thinking you might be seeing a little floating around yellow circle that maybe you'll like that, maybe it'll be a bit more helpful. Before we get going into solving exponential equations, let's take a look at a few of the exponent laws. What happens when you multiply two exponents that have the same base? What do you do with the powers? So you can think of x cubed as x times x times x times x to the fourth. Well, now that would be four of them. So this is the same thing as having 7 x's that are multiplying together. So this will give you x to the 7th. So really what do? You here, you add the two together. So it's going to be x to the 3 plus 4. So when the bases are the same, you add those powers. What about a power to a power? X to the fourth all squared. So x to the fourth, just like we had before, it would be 4x's multiplying times each other. And now if it's squared, that's multiplied by itself, right? So now we would have 4 more of them. So how many do we have multiplying all together? We have 8. So this is the same thing as x to the 8th power. So really what you're doing here is you're multiplying 4 times 2. So you're going to be multiplying. When it's a power to a power, you multiply those out. When you're dividing, it's the same thing as subtracting. So just like here multiplying, you add these two. Here we're going to be subtracting. You can imagine a very large fraction with 15 x's multiplying in the numerator and 3 x's multiplying in the denominator, and then you would cancel 3 out. So you would end up with x to the 15 minus 3 is equal to x to the 12th. Okay, one more thing I'm going to remind you of is how square roots or radical signs work. So if I have, say, the square root of x, another way of saying that, that's x to the power of 1/2. If you have the cube root of x, that'd be x to 1/3. Okay, and you could say, I don't know, let's say if we had x to the 5th power and the whole thing was square rooted, that would be x to the power of 5/2. So this 2 comes from the fact that it's a square root, and that 5 is because x to the 5th power. All right, now common exponents. Now you don't have to necessarily have all of these memorized, but it's a good idea to have gone through these common exponents so that when you see the number pop up, you can remember, oh yeah, that's what it is. So 2 to the 1 power is 2. 2 squared is 4. 2 to the 3rd power is 8. In fact, what I'm going to do is I'm going to pause and then give you a chance to see how many of these that you can figure out on your own. And if you can do it without a calculator, that'd be great. So I'll pause and then I'll be filling them out, and then we'll come back and see how you did. Okay, so I just did the ones with a base of 2, 2, 4, 8, 16, 32, and so forth. And so you'll see those happen quite a bit. You'll notice this 256. You'll notice that to the 8th power, that happens a lot. Say in computers, you get values between 0 and 255. 1024, like kilobytes, 1024 bytes in a kilobyte, and those types of things. Now I'll pause one more time, and if you haven't done so already, do the 3s, the 4s, the 5s, and the 6s. All right, there is my completed list. So once again, you don't have to have this completely memorized, but just the act of going through it, you'll when 216 shows up later on, you'll say, oh, I can't remember exactly what it was, but I remember it was on this list, so it's a power of something, and it won't take you too long to realize that 216 is the same thing as 6 to the 3rd power. So they'll become a bit more familiar, and you'll remember it a little bit easier. At the bottom of the page it says, if c to the power of x is equal to c to the power of y, then x must be equal to y. So this is the basis of the remaining of our exercises here. Here's an example. 3 to the power of x plus 2 is equal to 3 to the power of 7, so therefore x plus 2 is going to be equal to 7. And then if we subtract 2 from both sides, then we know that x is equal to 5. And if we plug it back in there, we're going to get 3 to the power of 7 is equal to 3 to the power of 7, so it works. Even without having to know what 3 to the power of 7 is, we can still solve for x. So let's do the examples on the next page. On this one, the problem is that the bases are not the same. So in our exercises today, the first step is always make some changes so that the bases are the same. So I remember from my chart we just did that 32 is the same thing as 2 to the power of 5. So now 2 to the power of x plus 1 is equal to 2 to the power of 5. So therefore x plus 1 is equal to 5. And so x is going to be equal to 4. That's kind of cool. So that's exactly how you do the first example. 3, and this one is a base of 27. I'm going to go, oh wait, I know that one. 27 is the same thing as 3 to the power of 3. So wherever I saw the 27, I'm now going to write 3 to the power of 3. Now that is to the power of 2x. Okay, and the left-hand side is still the same. So a power to a power, you'll remember we end up multiplying. 3 times 2x, just like one of our previous examples. So now we can say 4x minus 1 is going to be equal to, well, what is 3 times 2x? It is equal to 6x. Let's subtract 4x from both sides, and we will end up with minus 1 is equal to 2x. So we divide both sides by 2, and we get x is equal to negative 1/2. All right, now example number 3. Now we have 27 and 81. That again, we can convert that to an exponent with a base of 3. So 27 is going to be equal to 3 to the power of 4. Oh, sorry, 3. 3 to the power of 3. We'll try that one again. Which is equal to 81, which is 3 to the power of 4. And then that is to the power of 2x minus 1. So how do we combine these two? This is going to be 3 to the power of x plus 3 is going to be equal to, let's multiply those out, 3 to the power of 8x minus 4. Now we can drop this down and we'll get x plus 3 is equal to 8x minus 4. Subtracting an x from each side, I'll get 3 is equal to 7x minus 4. Add 4 to both sides, so I get 7 is equal to 7x. So x is equal to 1. Okay, on to the next page. Oh, are there more examples on the right? No. On to the next page. I think I'm missing. Okay, this is a repeat. That's the one I want. Okay, example number 4. Here I have a 2 and a 2 and a square root of 2. So 4 is the same thing as 2 to the power of 2, and then that is to the power of x plus 1 is equal to 2 to the power of x times 2 to the power of 1/2. So on the left hand side, the power to the power multiplies, so I get 2x plus 2 is equal to 2 to the power of, now remember to combine those with a single base, I'll get x plus 1/2. And so 2x plus 2 is equal to x plus 1/2. So I will subtract an x from both sides, so I get x plus 2 is equal to 1/2. And then I'll subtract 2 from both sides, so x is going to be equal to 1/2 minus 2, so 1/2 minus 4/2. So x will be equal to minus 3 over 2. Put a little box around that so you can find my answer nicely. Okay, example number 5. Okay, now the 3 is in the denominator. So just a reminder, just a little while ago we had x to the minus 2 was equal to 1 over x squared was an example of what happens when you have a negative. Really, we're going the other direction in this case, isn't it? We've got a base of 3 and it's in the denominator of this fraction. So I can say, well, that's going to be the same thing as 3 to the power of negative x minus 1. So what I've done is I've taken this out of the denominator and put it in the numerator and made this a negative. So it's like I've gone from this, right, this type of expression, and turned into that one, is equal to 81, which is going to be equal to 3 to the 4th power. So I have minus x minus 1 is equal to 4. So I have minus x plus 1 is equal to 4. So minus x is going to be equal to 3, and x will be equal to negative 3. You know, at some point, if you wanted to do, you can do a check on these as well. So let's try a check on this particular question. So we could do, it's not required, but just to see if we did things all right. So 3 to the power of negative 3 minus 1 is equal to 81. So 1 over 3 to the power of, this would be minus 3 minus 1 would be minus 4. So 1 over 3 to the negative 4 is going to be the same thing as 3 to the power of 4. And 3 to the power of 4 is 81. So it works out. Let's try number 6. Here we have a negative 8 to the power of 5 over 3 is equal to 2 times 4 to the power of x plus 2. So looking at this negative 8 to the power of 5 over 3, I guess the question is the negative being inside of that 8 expression? In other words, is it negative 8 to the power of 5 over 3? Or is it negative 8 to the power of 5 over 3? Do we include that negative with the power or not? And the answer is we don't. Okay, we can think of it as 8 being 8 to the power of 5 over 3 and then multiplied by negative 1. So this is not the one we want, this is the one we want. Okay, so is equal to 2 times 4 to the power of x over 2. Okay, so first of all, 8 is, the common base we're going to have is 2, so this is going to be 2 cubed to the power of 5 over 3 is equal to 2 times 2 to the power of 2 times x over 2. So now we'll do this multiplying here. So this is going to be the same thing as 2. What happens when we multiply 3 times 5 over 3? This 3 will cancel that 3 out, because this is like 3 over 1. When we multiply 3 over 1 times 5 over 3, we can cancel things out. And over here, same idea, we can think of this as a 2 over 1 times x over 2, so these two cancels, those two cancels each other out. So I get a 2 to the power of 5 is equal to 2 times 2 to the power of x. So I get a negative 2 to the power of 5 is equal to 2 to the power of 1 plus x. Now, I have to stop at this point because this is can be confusing. Is there any way that I could put an x value to turn this into a negative value? On the left, like 2 to the 5th is got a negative in front of it. So this side's negative. And this side over here, there is no way that I can make it a negative value. So if I make x, let's just say if I make an x a negative value. So let's say 2, 1 plus, I don't know, negative 3. I'm going to substitute an x as negative 3 just to sort of test things out. That's the same thing as 2 to the power of negative 2, which is the same thing as 1 over 2 squared, which is equal to 1/4. So if I make x a negative value, the way that works is I get 1 over some number. So it gets closer and closer to 0, but it never gets negative. The right-hand side is always positive. So because you've got a negative on one side and a no negative on the other side, the answer at this point is going to be no solution. Just to watch out for that. The other thing we have at the bottom of the page is a little note here. We cannot yet solve equations with different bases. And the important word here is yet. So it's coming. Okay, soon we'll be able to do that, but not quite yet. We can also solve these exponential equations graphically. So if we have this, here's a question that we need to solve graphically. We could solve it algebraically, but we'll do that in a second. We'll solve it graphically. We've done this before. You graph y equals 3 to the power of x minus 1 plus 2, and graph y is equal to 5, and find out where they intersect. So let's try graphing this first part here. Let's graph this y is equal to 3 to the power of x minus 1 plus 2. So the parent function here is going to be y is equal to 3 to the power of x. Just a reminder what that looks like. It kind of goes like this, right? And there are 2 points that we know all the time on this. We know that we have a 0, 1 point, and we have a 1, 3 point. So our image, well, what are we doing here? What does the -1 part? The -1 means that b is equal to 1, and we're going to go left 1. Sorry, right 1. Say it again. We're going to go right 1. Or another way of thinking of this, if we're going right 1, we're going to be adding 1 to our x values. Add 1 to x values. So on our image here, we can take a look at our x values, and for these 2 points, we're going to add 1 to them. We'll get to the +2 in a second. So 0 plus 1, we'll get a 1 here, and this 1 plus 1 will get a 2. I'm going to switch to blue for our next point. We also have a d value is equal to 2, so that means up to or add 2 to y values. So this +1, this is the x, this is the y value, I will have to add 2 to that, and I will get a 3. And I'll have to add 2 to this 3, and I'll get a 5. Okay, so maybe I'll do it in red first. My original function would have gone here, 0, 1, and then it would have been 1, 3, and I would have had a nice, I'll try to draw it nicely. This is how it would go originally, up high like that, and it would have an asymptote, y is equal to 0, horizontal asymptote. Now with our image, we would have a horizontal asymptote because everything is up to, because of that d value of +2, it's going to be y is equal to 2. So I will erase what I had here, and I will move everything up 2. I'll just leave these 2 points in here for now, and the 1 and the 3. Okay, so I need to go right 1 and up 2. So right 1 and up 2, so this point now becomes 1, 3, so this point actually moves where that second point was, and the 1, 3 goes right 1 and up 2 to 2, 5, and there is a horizontal asymptote at y is equal to 2, so I have this asymptote here, and my function is now going to go something a bit more like, I'll try in here. Okay, like that. So that is my first line, that y is equal to 3. This is y is equal to 3 to the power of x minus 1 plus 2. The second line that I need to draw, maybe I'll go back to red for that, is the y is equal to 5, and this is the y is equal to 5. And so pretty clear that our solution is right there. So our solution is the x value is 2 and my y value is 5. So when x is 2, y should be 5 for both of those. So since y is always 5 regardless of what x is, that's true. And if I put an x for 2 in here, I should get a 5. And I think that's what the very next part says underneath. Verify your solutions algebraically. So to verify means to plug in a number and find out whether it's true. So let's just see. Y is equal to 5. That is 2, 5 is a point on y equals 5. That's nice. And what about our y is equal to 3 to the power of x minus 1 plus 2. So if I put in an x for 2, do I get a 5 for y? So I'll put a 5 here is equal to 3 to the power of 2 minus 1 plus 2. So when x is 2, when this x is 2, do I get a 5 for my y value? Okay, and it is true because 5 is equal to 3 to the power of 1 plus 2. So that is true, 5 is equal to 5. All right, I hope you do well with your homework, and I'll see you in class.